Hello everyone. I finished grading all the Unit 3 guided notes you have submitted. After grading those work, I selected the following problems I want to go through here. The first problem is question number 3b, and it's ask us to simplify the given expression. Okay, B looks a little bit complicated, but let's do step by step. The initial expression is 5 times a negative second power times b times 2 times a negative 2 second power b cubed over 3ab negative 2. So in this expression, we have the following options: exponential operation, fraction as division, and we also has a lot of multiplications. Okay, so let's do step by step. The first thing we want to do is get rid of the exponents, or we can say, no, we cannot get rid of them, but we can deal with the negative exponents first. So we know that from your part 1 in Unit 3 guided notes, I mean the first problem, you should know the laws of exponents. So a to negative second power, so you are going to have, because of this negative sign, you are going to find a's reciprocal, which is 1 over a squared times b. Okay, same thing here. Because of this negative 2, you are going to find the reciprocal of this fraction, which is 3ab over 2a negative second b cubed then squared. Make sense? Okay, let's distribute. When you do positive exponent, you are going to distribute the exponent to both numerator and denominator. So it's become 5 times 1 squared is 1a squared is a squared times b times. Here is the same thing. You are going to distribute this squared to both numerator and the denominator. 3 squared, 9. A squared, b squared. And then 2 squared is 4. And a negative 2 then squared is a negative 2 times 2, which is negative 4, times b cubed then squared is b to 6th power. Okay, so let's continue. At this time, we still have a negative 4th power as the numerator here, so we're going to flip this. Since this a right now is as the denominator, part of the denominator, because of this negative 4, we're going to put a to 4th power to the numerator. Okay, it's 5 times 1 to a squared times b, so now the numerator becomes 9 times a squared b squared times this a to 4th power. So negative exponents usually is, if it is in the numerator place, put it in the denominator, get rid of the negative sign. If the term part is part of the denominator, you get rid of this negative sign, then put as the numerator. Okay, it's denominator left as b 4 times b to 6th power. So now let's do multiplication. So 5 times 9 fourths, 5 times 9 fourths we will do in a minute. And then let's take a look at all the variables on the numerator. We have a b, we have a squared, we have b squared, we have a to 4th power. And the denominator right now left as a squared, and then this b to 6th power. Okay, let's continue. So 5 here is 5 over 1. So multiplication with fraction is numerator multiply together, 45. Denominator multiply together is 4. So let's do the operations on the numerator. So a squared times a to 4th power become a to 6th power. You are going to add the exponents together. 2 plus 4 equals 6. So here is b to 1st power and b to 1st power and b to 2nd power, which is total b cubed, okay? So denominator still a squared, b 6th power. 45 over 4. Since when we have a 6th power divided by a squared, so we're going to subtract the 6 by 2. Subtract this 2 from 6, which is a to 4th power, okay? And for b cubed divided by b to 6th power, you could do the same. Say b 3 minus 6. Remember, always do numerator, the exponent on the numerator, subtract the exponents in the denominator. So it's 3 minus 6, which is negative 3. Remember, it's negative 3. You could leave the final answer as this. It's acceptable. Or you could, if you want to get rid of this negative exponent, you could do 45 over 4 times a to 4th power. Remember, because of this negative sign, you are going to find b's reciprocal, which is 1 over b, then cubed. Overall, you could rewrite as, okay, numerator we have 45 a to 4th power. Denominator we have 4, we have b cubed. So that's the final answer. Okay. So the next problem I want to talk about is question number 8. Question number 8 says that solve the equation below by factoring 2x squared minus 5x equals 3. Factoring, so you are going to move all the terms to the left side, the right side as 0. So we're going to subtract 3 to both sides. Become 2x squared minus 5x minus 3. And 3 minus 3 becomes 0. So we rewrite the equation in this format. The next thing we're going to do is to factor the left side. We have learned this from Unit 2, okay? If you remembered, the first thing you are going to do is the first coefficient 2 times the constant negative 3, which is negative 6. The next step, you are going to factor negative 6 to see which two numbers multiplied together equals negative 6. At the same time, those two numbers added together equals the coefficient of x term, which is negative 4. Negative 5. So we knew that so if you had enough practice, you could easily find that negative 6 times 1 is negative 6, and also negative 6 plus 1 equals negative 5. Okay, so now we found the two numbers. One is negative 6, one is 1. So you are going to factor the left side as 2x, and this is 1x. And oh, sorry, I missed one step. So we're going to use these two numbers to split this negative 5x to negative 6x plus 1x. Okay, So I'm going to copy the rest. So for the first two terms, we share 2x as the common factor. This term left x, this term left a 3, because 6 divided by 2 equals 3, plus x minus 3 equals 0. And then you see these two terms shares x minus 3, so you put x minus 3 outside, and left 2x plus 1, because 1 times x minus 3 gives you this term. So right now we factored the initial equation, and using zero product property, say when two numbers multiply together equal 0, one or both should be 0. So x minus 3 could be 0. 2x plus 1 could be 0. Either this or both, okay, can always make x minus 3 times 2x plus 1 equals 0. So let's solve these two equations. X equals 3. This one a little bit more complicated, so you are going to minus 1 to both sides, left negative 1. Remember, it's 0 minus 1 give us negative 1. So now you are going to divide it by 2 to both sides, become negative 1 half. X could be 3, x could be negative 1 half, okay? And so those are the solutions, answers to the equation. So some students tried to represent the x in a set notation. Should be 3 and negative 2, okay? So you should use these brackets. Some students used 3 negative 1 half, or negative 1 half 3, but we for set notation, we will not use these brackets because this will be confused with the interval notation. So not this bracket, okay? And also some students made mistakes. They made a mistake like 0 minus 1 equals 1, which is not right. Okay? So that's the answer. Or you could just write the set notation as 3 and negative 1 half. That's question number 8. So the next question I want to talk about is question number 14b. Okay. Question number 14b. The initial equation is 4x squared minus 2x plus 1 equals 0. You are asked to use the quadratic formula. So to use quadratic formula, the first thing you need to do is figure out b squared minus 4ac, whether this is greater or equal to 0. Oh, okay, so we call this the discriminant of the quadratic equation because the sign of this term or the value of this discriminant determines whether we have real solutions or not, okay? So in this case, we have b squared is negative 2 squared minus 4 times a is 4, c is 1. So we have 2 squared is negative 2 squared is 4, minus 4 times 4 is 14, which is negative 12. The discriminant of this equation is a negative number. Some students say because it's less than 0, no real solution. It's right. If you stopped here, say no real solution, because of this less than 0, I accept that. And some students continue doing that, saying no real solution, but has imaginary solution. Let's use the quadratic formula to solve that. So the formula tells us 2 times a, which is 4. Negative b is negative 2. Remember, negative b in this case is negative 2. So we have two negative signs here. Plus, minus square root of the discriminant. Since I solved this already, I will just copy the negative 12 here. So denominator 8, negative give us positive. Become plus minus. So you could rewrite this negative 12 as negative 1 times 12. Okay? And you could split this to 2 square root. 2 plus minus negative 1 times square root of 12 over 8. Sorry, baby is crying. So 2 plus minus negative 1 square root give us the imaginary number I. This is 4 times 3. 4 square root of 4 give us 2, and left the 3 inside of the square root over 8. Finally, we see that the numerator and the denominator share a common factor of 2. So 2 divided by 2, 1, plus minus. These 2 divided by 2 become 1, then left only square root of 3. Remember I is outside of the square root, okay? 8 divided by 2, which is 4. So the answer will be x equals either 1 plus square root of 3i over 4 or 1 minus square root of 3i over 4. So that will be the imaginary solutions, okay? Imaginary numbers as the solution to the initial equation. You could either leave as no real solution, or you could continue and finally find the imaginary numbers as the solution. Okay, so question number 19 is another problem I want to talk about. Question number 19. So the equation of a circle is x plus 5 squared plus y minus 2 squared equals 16. We knew that the center of this circle is negative 2 and positive 2, negative 5 and positive 2. And the radius is 4. Here is center. Center is a point, negative 2 and negative 5 and 2, and the radius is 4. The reason I want to talk about this is many students try to graph this point. They didn't graph as, so negative 5 and 2 should be, so this is x, this is 5, y, then negative 5 for x will be 1, 2, 3, 4, 5. Here's negative 5, and then y 1, 2. So the center should be here. Some students plot here 1, 2, 1, 2, 3, 4, 5, and plot the center here, but actually this point representing 2 and a negative 5, not negative and 2. Some students plotted the other mistake students made was here. Negative 5 and negative 2. One student made a mistake here. So overall, you need to be sure that the first number is about the x value, okay? X coordinate. So should be go to the negative side of x-axis. 5 units, negative 5. Then for y coordinates is positive 2, so you should go up 2 units and then find the negative 5, positive 2, and the center is here. So for Unit 3, the last problem I want to talk about is from the activity. Question number 2. You were given a quadratic equation x squared plus 6x minus 11. Okay, the first thing you were asked to do was complete the equation using complete the square. So if you truly understand the given example, the first thing you need to do is move the constant to the other side. So we do that by plus 11 to both sides, become x squared plus 6x equals 11. The next step you are going to do is figure out half of this one. Half of 6 is 3. Then squared it. 3 squared is 9. So you square this number, half of the 6, once. You square 3 once and 9. You are going to add 9 to both sides. And because x squared plus 6x plus 9 equals, so the right side equals 20. The reason we plus 9 to both sides, because on the left side, this makes a perfect square. So, and you need to remember, this 9 is from 3 squared. 9 is from 3 squared, so become x plus 3 squared. So the left side is a perfect square equals x plus 3 squared. If you want to double check, x squared is this term. 3 squared is this 9. You also need to plus twice of these two multiply together. 3 times x, twice of it is 6x equals 20. So I would call this perfect square property. So when a number squared equals 20, this number could be positive or negative of square root 20. Okay, or if you think a little bit confusing, let me separate them. Say a number squared equals 20, so this number could be positive square root of 20, or this number could be negative square root of 20. Okay, so let's solve the first equation. So we solve it by subtract 3 to both sides, become negative or square root of 20 minus 3. So remember, square root of 20 can rewrite as 4 times 5. Square root of 4 is 2 times that square root of 5 minus 3. So the answer will be 2 square root of 5 minus 3. Same thing here, we subtract 3 to both sides, become x equals negative square root of 20 subtract 3. So x become negative 2 square root 5 minus 3. Okay? If you have any questions, feel free to let me know. I do encourage you to watch the video because we all learn from our mistakes, okay? I picked all these problems because many students made mistakes in these problems.